here with data science teacher Brandon, and today we're going to go over the seaborn displot. So DIS plot, not the dist plot. That is decapitated now, so this is the facet level plot with the DIS, so for distributions. Okay, so looking at the first one, we'll go SNS dot displot data equals df, x equals our continuous variable, or y equals our continuous variable. And I'm going to turn KDE equals to true here. And this is going to give us the nice little line, the kernel density estimation line, which helps generalize the data a little bit, but can help really inspect it a little bit more. Sometimes being a little bit general can help us see things that we might have other missed if we get stuck down in the weeds in too much detail. Okay, so here we're going to do that one. Now, because this is a facet level grid, what we can do is call the argument col or row to separate this. So here what we're doing is gender female, gender male. We're plotting the distribution of math scores for each one of those categories when they're true. Okay, so we can take this up a step and we can add, so we added a column argument, and now we're going to add a row, so row lunch. And you can see here we have lunch standard, gender female, top left, and we can see the distributions lunch free, gender female. So this is the difference between eating a lunch, and you can actually see those distributions look quite different, which really surprises me. You wouldn't have thought eating lunch would make that much of a difference, but apparently it does have quite a substantial effect. Okay, here we can see here in the next one, with seaborn, we always have access to the hue arguments. We're able to separate this now by up to 3 categories. Okay, and we can see here we have standard lunch, gender female, when the test preparation was none, and then the test preparation was complete. And you can see here, you always see a little bit of the separation, a little bit more when it was complete on the higher end. For all of the distributions, it seemed to make a pretty consistent change. But you can see the distributions in general tend to have quite a different play. You can see here that just the formation, here the test preparation none is a lot more weighted to the lower side than the test preparation completed. So it really does, although we can see a little bit different, having the KDE line gives us a sense of the overall distribution that can be really valuable, especially when inspecting things by the hue argument. So thank you very much for joining me today, and I will see you next time.